Number 8. Let f be a function defined by f of x equals k rad x minus natural log of x, where x is greater than 0. All right. Now, if you think about the domain just of f, what's the domain? Just naturally from the function itself. X has to be greater than 0. Why? You can't take the square root of a negative, number 1, but you can take the square root of 0. Right? But what about natural log? You can't take the natural log of 0 because it's approaching, x could be approaching 0 but not be 0. So it gives you the domain. That's nice. And k is a positive constant. Keep that in mind. Part A, we're looking for f prime, so that should be easy enough. F prime of x. What rule? Product rule? No, not product rule. Let me rewrite. Chain rule, maybe? I'm going to rewrite f of x as what? Kx to the 1/2 minus natural log of x. Then we can take the derivative. So f prime of x equals. K is a constant. It's a positive constant. So we get 1/2 k x to the negative 1/2 minus 1 over x. And we can simplify that a little bit. We might need to for the future. So I'm going to, just for the heck of it. So the x to the negative 1/2 goes to the bottom. So I end up with what? K over 2 rad x minus 1 over x. Okay, so that's f prime of x. And then it says find f double prime of x. Well, I'm going to still use this one. Actually, I want to change that so I can take the derivative easy enough. So f prime of x equals 1/2 k x to the negative 1/2 minus x to the negative 1. If you want, you could do the quotient rule on it, but that's just more work than it's worth. So f double prime is equal to what? Negative 1 over 4 x to the, k x to the negative 3/2, and then this will be plus x to the negative 2. So just rewriting that a little bit, we would get negative k over 4 x to the positive 3/2. And then plus 1 over x squared. So 2 points, one for f prime, one for f double prime. That was easy, yeah? Now, maybe we're going to need f prime and f double prime for the other parts. We'll see. Part B, for what value of the constant k does f have a critical point? How do you find critical points? When f prime doesn't exist. Okay, so let's look at f prime. When does it not exist? When x equals 0, but that is outside the domain, so we don't have to worry about that one. What's the other type of critical points? When f prime equals 0. So let's do that. So critical points are when f prime equals 0. So we're going to say, I'll just write this, f prime equals 0, and then we'll solve it. 0 equals k over 2 rad x minus 1 over x. Now there was one other part to this. It said, for what value of the constant k does f have a critical point at x equals 1? So it's telling us what the critical point is. So what do? Plug in 1 to x. So 0 equals k over 2 rad 1 minus 1 over 1. Well, that's nice. 0 equals k over 2 minus 1. So I guess 1 equals k over 2. So k equals 2. Well, that's for the first question in part B. It says now for this value of k, determine whether f has a relative min, relative max, or neither. How do you determine whether... We got to figure out if it changes signs, right? And see what kind of signs it changes. So if k equals 2, we're going to plug that back into f prime. So then I'm going to write it like this. F prime of x equals what? 2 over 2 rad x minus 1 over x. So f prime of x equals 1 over rad x minus 1 over x. Now we look at our number line at x equals, or around x equals 1. So we know the critical point is when x equals 1. We know 0 does not exist, so we don't have to consider that. So pick a number. 1/2. Okay. This is going to be positive. This is going to be negative. But what's a positive minus? Depends which one's bigger. So let's just figure it out. F prime of 1/2 equals 1 over, I don't like 1/2. Because the square root of 1/2, I don't know. But I do know the square root of 1/4. So let's get rid of the 1/2 and say 1/4. Minus 1 over 1/4. What's the square root of 1/4? So it's 1 over 1/2 minus 1 over 1/4. What's 1 over 1/2? 2 minus what's 1 over 1/4? So we get negative 2. So this value is negative over here. Now what? Plug in 4. That would be a good one. So f prime of 4 equals 1 over rad 4 minus 1 over 4. So that's 1 over 2 minus 1 over 4, which is 1/4, which is positive. So what do we have when x equals 1? Relative minimum. So I'm going to get rid of this because that's just chicken scratch. So we'd say f has a relative minimum when x equals 1, since f prime changes signs from negative to positive. All right, so that was worth 4 points. I'm thinking you're going to get 1 point for finding the k value, 1 point for finding, or 1 point for saying relative minimum, 1 point for the justification, and probably 1 point in here for showing f prime equals 0. Okay? Are you guys good with that? So 1 point for showing that f prime is supposed to equal 0 to find the critical point. 1 point for finding k. 1 point for your answer about relative minimum. And 1 point for f prime change in signs from negative to positive. Are we good with that? All right, we've got part C left. Let's read part C before we erase anything. For a certain value of the constant k, the graph of f has a point of inflection on the x-axis. So how are we finding a point f double prime? And here's the interesting thing. It says f has a point of inflection on the x-axis. What does that tell us? If the point of inflection occurs, it's going to look something like this. It's got a point of inflection on the x-axis, something like this, right? Say it again? Well, this would be like f graph, because it's changing concavity. It would be, if this is f double prime, it would be changing f would be changing concavity too. But the point is, f has a point of inflection on the x-axis. So there. So what is the coordinate here? I'll just put a question mark, comma, 0. Keep that in mind. So let's get rid of B. We still need part A because we're dealing with what? F double prime. So we're looking for when the point of inflection is on the x-axis. So let me rewrite f double prime. Man, negative k over 4x to the 3/2 plus 1 over x squared. So what's the first thing that must happen? Set it equal to 0, okay.
Is k still 2? Or?
No, we're trying to figure out another k value that makes this true. So that's when a point of inflection might occur. We also have to check change in signs, but what else? What else did it tell us? It said f has a point of inflection on the x-axis. So what's that tell us? It's when what? Y is 0 of what function? Of f. So what we're going to do is set f equal to 0. So 0 equals k x to the 1/2 minus natural log of x. Wow, that's gross. That's one thing we've got to consider later. I'm going to simplify this by adding this to both sides. So I get k over 4x to the 3/2 plus, equals 1 over x squared. You guys okay with that? Yeah. Cross multiply maybe. So you get kx squared equals 4x to the 3/2. And divide by x squared, because we're trying to solve for k, right? Trying to solve for k. So k equals what? 4x to the 3/2 over x squared. So what would that be? 4 over rad x. But I got to find the x value. No. What? Somebody's coming up with something. What? This must be equal to, or this must be true and this must be true, right? So let's plug this value into k. So we would end up with 0 equals k times, 0 equals 4 over rad x times rad x minus natural log of x. So you get 0 equals 4 minus natural log of x. Natural log of x equals 4, so how do I solve for x? E to the 4th equals x. No. It says find the k value. Oh my goodness. So x equals e to the 4th. Now it says find the k value. So let's just plug it in right here. So then k equals 4 over radical e to the 4th. So k equals, could it be a negative e squared? It could be. Well, hold on. There's a key to this, okay? Because the square root of e to the 4th could be, negative e squared or positive e squared, because when I go to square it, I'll get that, right? But what did it tell you about k in the original part of the problem? K is a positive constant, so k equals, that I believe is it. So 3 points, you're going to get a point for something. Looks like you're going to get a point for solving for k here. So you got to set f double prime equal to 0, solve for k. You're going to get a point for solving for x, and then a point for solving for the correct k. Okay?